Hello everybody, welcome into another lesson. So today we are going to talk about factoring quadratic equations. And these type are where it's not a perfect square trinomial or difference of squares. Now granted, you can use this method on perfect square trinomials, you're just doing a little more work than you need to, but this is really good for if it's not a perfect square trinomial. So everyone by now, I'm sure, has seen the standard form of a quadratic equation, ax²+bx+c, where of course you have your x squared term, a is the coefficient on that, then you have your x to the first term, where b is the coefficient on that, then you have a constant, which is c, some arbitrary constant. Well, today we're going to talk about the case where the coefficient on the x squared term is 1, and it's only 1. So that's going to make our lives a lot easier. Now in the next lesson we'll talk about when it's anything other than 1, which is where it gets a little bit tougher. But today's will be a piece of cake. I'm going to show you what we do here. So the first one we have is x squared plus 5x plus 4. Okay, so whenever you have the coefficient, and this is going to be true for all the problems today, whenever you have a coefficient of 1 for your x squared term, the only thing you have to worry about is what are your factors of your third term, your constant term. What you're going to do, figure out what your factors of that constant term are, and then find the right factors and add them together that create the coefficient of the middle term. So in other words, what are some factors of 4? We have 1 and 4, right? 1 and 4 are factors. Well, if you add 1 and 4, you get positive 5. So right there, we can stop. How's this going to work? You're, of course, going to have a quantity of x. Then we said 1 and 4, we only have to worry about positive factors since the sign on both the middle and last term is positive. So you'll literally just take x plus 1 times the quantity of x plus 4. So literally it's just x plus 1 times x plus 4. It reduces down into two binomials, which are to the first degree. And then if you FOIL this out, you'll get x squared plus 5x plus 4. So those are relatively easy. Alright, how about x squared plus 9x plus 14? So we have x squared plus 9x plus 14. Well, what are some factors of 14? Well, 1 and 14 for starters. Since everything's positive, we're only going to consider positive factors. 1 and 14, but if you add them together, you would get a middle coefficient of 15. 1 and 14 doesn't work, but how about 2 and 7? If you add 2 and 7 together, you'll get a middle coefficient of 9. So literally you're going to take then x plus 2 times the quantity of x plus 7. So it's always going to be, for your quantities, x plus one factor times the quantity of x plus another factor of the constant term. So you'll literally get the quantity of x plus 2 times the quantity of x plus 7. How about x squared plus 13x plus 40? So we have x squared plus 13x plus 40. Well, okay, so what are some factors of 40? And since everything's positive, we're only concerned with positive factors. What are some factors of 40 that would give you, when you add them together, that would give you 13? Definitely not 1 and 40, you would get 41. How about 2 and 20? Well, you would get 22, no. 4 and 10? Close, it would give you 14, but still doesn't give you 13. But what about 5 and 8? Yes, 5 and 8, if you add them together, would give you a middle factor of 13. So you're literally going to take x plus the one factor of 5 times x plus the other factor of 8. It would reduce down to that in your factored form. X plus 5 times the quantity of x plus 8. Now we're going to shift just a little bit here. So we have x squared minus 4x plus 3. Okay. So up till now, everything's been positive. Now this is a little bit different here. So x squared minus 4x plus 3. In a situation where your middle term has a negative coefficient, but your constant term is positive, you're only going to consider negative factors of your constant. So you're going to take negative factors of 3 that would add up to negative 4. So what are negative factors of 3? What if I take negative 1 and negative 3, right? Because negative 1 times negative 3 equals 3. But if I add negative 1 and negative 3, I'll get that middle coefficient of negative 4. So literally you're going to take the quantity of x plus negative 1, which would be x minus 1, times the quantity of x plus negative 3, which would be x minus 3. So there is your factorization. It would be the quantity of x minus 1 times the quantity of x minus 3. Alright, we have x squared minus 8x plus 12. Alright, so x squared minus 8x plus 12. Again, your middle term is negative, but your constant term is positive. That means we have to only consider negative factors of 12 that when you add them together will give you a middle constant of negative 8. So we definitely have negative 1 and negative 12 for factors of 12. Well, you add them together, you would get negative 13. That doesn't work. How about negative 2 and negative 6? Well, if you add negative 2 and negative 6 together, you'll get negative 8. So there you go. You would end up with literally x minus 2 times x minus 6. That would be your factorization for this. The quantity of x minus 2 times the quantity of x minus 6. Alright, we have x squared minus 16x plus 51. That's going to be a fun one. So x squared minus 16x plus 51. Again, your middle term is negative, but your constant term is positive, so we only consider negative factors of 51. Well, we definitely have factors of 51 are going to be, we have 1 and 51, right? So if you take, negative 1 and negative 51, you add them together, you get negative 52. That's just not going to work. So next then, the very next one we have is going to be 3 and 17. Negative 3 and negative 17. Add them together, you get negative 20. And really, there's nothing else we have. So this is not factorable. You can't factor this. This is not factorable because there are no factors that would give you negative 16 in the middle. Now, if you were to try to solve a quadratic equation for this, you could still solve it. It's just that's where you get into stuff like completing the square or, you would either complete the square or use the quadratic formula, which we'll get into those in other lessons, but you're not always going to be able to factor, unfortunately. Alright, so how about a squared plus 3a minus 10. Alright, so this just changed again. So, let's just look only at the constant term. The constant term is negative. Now, this is where you have to consider factors of negative 10. So that means for each one, you're going to have a factor of that's one that's positive, one that's negative. So let's start here. How about 1 and negative 10? Well, because 1 times negative 10 is negative 10, but if you add 1 and negative 10, you'll get negative 9 for your middle coefficient. That's not going to work. This time, negative 1 and 10. If you add negative 1 and 10, you get positive 9. That's not going to work. How about negative 2 and 5? So if you add negative 2 and 5, well, what do you know? You'll get a positive 3. So you're going to take your a, you're going to add negative 2, which would be a minus 2. Then you're going to take another a, and you're going to add 5. And if you FOIL this out, you would get exactly the original expression. So you'll get the quantity of a minus 2 times the quantity of a plus 5. Alright, see, we have b squared plus 6b minus 27. Alright, so we got b squared plus 6b minus 27. So again, the constant term is negative. That means for each factor of 27, we got to consider one positive and one negative factor that when you add them together will give you a positive 6 coefficient for the middle term. Well, good place to start, negative 1 and 27. If you add those together, you would get positive 26. Not going to work. Let's flip it around, 1 and negative 27. If you add 1 and negative 27, you would get negative 26. Not going to work. So how about negative 3 and 9? Well, if you add negative 3 and 9, you'll get positive 6. So literally, since you're adding negative 3, it's going to be b minus 3 times the quantity of b plus 9. And that's all you would have. So the quantity of b minus 3 times the quantity of b plus 9. All right, c squared plus 2c minus 80. So we have c squared plus 2c minus 80. Well, let's figure out factors of 80 that will, well, since the 80 is negative, we got to have one positive and one negative factor for each that, when added together, will give you a middle coefficient of 2. Well, let's start with negative 1 and 80. If you add those, you would get a middle coefficient of 79. Definitely not. So how about 1 and negative 80? If you add 1 and negative 80, you would get negative 79, not working. How about negative 2 and 40? You add negative 2 and 40, you would end up getting 38, still not working. So 2 and negative 40, you would get negative 38, not going to work. How about negative 4 and 20? You add negative 4 and 20, you would get 16, still not working. Then 4 and negative 20, you would get negative 16. But how about negative 8 and 10? If you add negative 8 and 10, you'll get positive 2. So literally, you're going to take then c minus 8 times the quantity of c plus 10. And if you FOIL this out, you would get that c squared plus 2c minus 80. So you'll have c minus 8 times c plus 10. I got about 3 more and we are done. So we have p squared minus 5p minus 6. Alright, so p squared minus 5p minus 6. Well, the middle coefficient is negative this time. But that's okay. Just focus on the fact that your constant term is negative. again, since your constant term is negative, you're going to want to take factors, one positive and one negative, for the -6 that when added together will give you a coefficient of -5 in the middle. So let's start with -1 and 6. You add those together, you get +5, so no. But 1 and -6, if you add 1 and -6, you'll end up getting the -5. So since you're going to have a +1, it'll be p plus 1 times the quantity of p minus 5. Or p minus 6, excuse me. What am I saying? So this would factor into the quantity of p plus 1 times the quantity of p minus 6. I got two more and we're done. This time we have q squared minus 7q minus 10. Interesting one here. So again, yes, it's true your middle coefficient is negative and your constant term is negative. So we need to figure out a positive and a negative factor for -10 that when added together will give you a middle coefficient of -7. Well, let's start with -1 and +10. You add those together, you would get +9, definitely not working. So how about 1 and -10? You add 1 and -10, you would get -9, not working. So since you have a -10, we need to, next we'll deal with -2 and 5. You add those together, you get +3, not working. So then we'll deal with 2 and -5. If you do 2 and -5, you add those, you would get -3. And that's all the factors we have. So this is not factorable. Again, some of these are not always going to be factorable. And right now, we're not going to put in the quadratic formula and solve this or do anything like that. That's coming, but we're only concerned with today, and in the next lesson, can we factor it? That's it. All right, one more. Last one, r squared minus 14r minus 72. So we have r squared minus 14r minus 72. Well, what are some... So the middle coefficient is negative, your constant term is negative, so we need to take a positive and a negative factor of -72 that when added together will give you a middle coefficient of -14. So obviously -1 and 72, you add those, you would get +71. That doesn't work. 1 and -72, that would give you -71. Sure, not working. -2 and 36, that's going to end up giving you +34. That doesn't work. So how about 2 and -36? That would give you -34. No. -3 and 24, that would give you +21. No. How about 3 and -24? That would give you -21. Nope. So let's see, how about -4 and 18? If you add -4 and 18, you would end up getting +14, so we're real close. So that means it's got to be 4 and -18. If you add 4 and -18, you'll end up getting that -14. So it's literally going to then be r plus 4 times r minus 18. And if you FOIL this out, you would in fact get this original expression. So this factors into r plus 4 times r minus 18. So that's it for this lesson. Next lesson, we are going to factor similar equations, only where the leading coefficient is not 1. It'll be anything other than 1. So I hope everyone has a great day. Take care.